Hello everyone. Welcome to the class of Construction Equipment Installation Project. In this video, we will discuss the cable TV system, mainly from two aspects: the concept of cable TV system and an introduction to cable TV system. The emergence of cable television systems can be traced back to the public antenna system in the late 1940s in the American mountain village. By the early 1950s, this viewing system had a very simple front end, which could achieve direct mixing and effective distribution of signals for a few open-circuit TV channels. This was the early Common Antenna System, CATV, in the early 1970s, with the practical application of communication satellite transmission of TV signals using CATV system to achieve common reception of satellite TV became a feasible solution. CATV gradually developed into today's true cable TV system. Since the late 1980s, cable TV systems have begun to transition from CATV to Integrated Information Service Networks. In China, in 1964, the former Central Broadcasting Bureau specifically initiated research on common antenna systems, marking the beginning of China's development of cable television systems. In January 1974, China's first common antenna television system was installed in a Beijing hotel, marking the birth of China's cable television system. Common antennas began to gradually appear on the roofs of residential buildings or bungalows. After the 1980s, analog cable television systems began to appear, and since the 21st century, digital television systems have emerged and become increasingly popular. At present, we are in the process of 3 network integration of television networks, telecommunications networks, and computer networks. In the future, a comprehensive system of full-featured service network, integrating broadcasting and television, communication, digital information, computers, and various service functions will emerge. This requires us to constantly learn, explore, and achieve it. We must firmly grasp the autonomy of innovation and development. Take the path of independent innovation with Chinese characteristics and be at the forefront of the world, like 5G technology. Next, let's learn about cable TV related content. Cable television system, CATV, is a television system that uses radio frequency cables, optical cables, multi-channel microwave distribution systems, or a combination thereof to transmit, distribute, and exchange sound, image, and data signals. The system consists of signal source equipment, front-end equipment, trunk transmission, user allocation network, and user terminals. The diagram is a schematic of a cable television system. The front-end system mainly includes signal sources and front-end devices. The signal source provides various signals to the system to meet user needs, such as satellite signals, microwave signals, etc. The signal source is a crucial part of the cable television system, and its content and quality determine whether a system has vitality and attractiveness. Signal source equipment typically includes satellite ground stations, microwave stations, higher-level cable television networks, television relay vehicles, video recorders, cameras, television projectors, etc. Front-end equipment is a device between the signal source and the trunk transmission, which performs necessary processing on the received signal source and outputs high-quality signals To the trunk transmission system. The main front-end equipment includes antenna amplifiers, channel amplifiers, channel processors, modulators, mixers, etc. The trunk transmission system transmits high-frequency television signals provided by front-end equipment to the distribution system through transmission media without distortion. The trunk section mainly includes various types of amplifiers, equalizers, optical transceivers, etc. Its transmission methods mainly include fiber optic, microwave, and coaxial cables. When the system scale is small, less than 2,000 households, and the transmission distance is less than 1.5 kilometers, coaxial cable can be used. When the scale is large and the distance is far, a hybrid network transmission method of fiber optic coaxial cable should be used, with fiber optic to the service area and coaxial cable used for the last kilometer. The user allocation system distributes signals from the front end to various user points. The main equipment includes distribution amplifiers, branch distributors, onboard converters, and branch lines between them. The main components of a general user allocation system include user allocation amplifier, splitter, distributor, RF cable, and user terminal box. The user-assigned amplifier is an active component, while the splitter, distributor, RF cable, and user terminal box are passive components. User allocation amplifier, also known as floor amplifier, branch extension amplifier or building amplifier, is a device that amplifies cable TV signals, as shown in the following figure. The distributor distributes the TV signal from the input port evenly to each output port. The output signals are isolated from each other, and there will be no crosstalk phenomenon. The signal's output by each channel will have a certain attenuation compared to the input signal, and the attenuation is also the same. Distributors can be divided into 2 distributors or 3 distributors, based on the number of output terminals. The left image divides the signal from the input port into 3 output ports. Hence, it is a 3 distributor. Similarly, the right image divides the signal into 4 distributors. A splitter extracts a portion of the signal from the cable line and outputs it to the branch interface, while the remaining signal is still output along the original line. It only has 1 output port, and the rest are several branch interfaces. The attenuation of the output port is very small, while the signal attenuation of the branch interface is large. It cannot be used as a trunk connection for branching in series anymore, and is usually directly connected to the terminal. Branching devices can be divided into 2 branching devices or 3 branching devices, based on the number of branches. The left image only has 1 output port, and there are 2 branch interfaces, so it is a 2-branch splitter. There are 3 branch interfaces in the right figure, so it is a 3-branch splitter. It should be noted that the output terminal of the allocator should not be left blank. The branch interface terminal of the splitter can be left blank, but the main output terminal cannot be left blank. According to the characteristics of allocators and splitters, they can be combined into various allocation methods. In the distribution network, all adopt the allocation method of the allocator. All adopt the branch method of branching, used for multi-story and high-rise buildings, with the same vertical position on the user side, and arranged in a series up and down, to save pipelines, known as the allocation branch method. The allocation method is suitable for structural forms, that spread outwards from the front end as the center. If the length of each cable is equal, then the output frequency of each cable is also equal. The allocation loss is relatively small, and the loss of the entire allocation system is the sum of the allocation losses of the 2 distributors and the 4 distributors, plus the loss of the cables. The disadvantage is that if one circuit is empty, it will have a significant impact on the other circuits. Therefore, when one of the output terminals is temporarily unused, a 75 ohms matching load must be connected, which is mostly used for mainline distribution. Branch method refers to the allocation method, in which the system uses all branching devices and is suitable for situations where the structure is dispersed and the trunk line is long. Therefore, at the end of the main line, a 75 ohms matching load should be connected, as shown in the figure. The allocation branch method combines the above 2 methods by first passing the signal output by the amplifier through a distributor, dividing it into several main branch lines, and then using a splitter to distribute each line. This allocation method takes advantage of the advantages of the 2 distribution circuits mentioned above, as the previous part uses a distributor to minimize losses, and also adopts branch output. The user side does not care about the impact of idle load caused by the TV not being connected to the circuit. Therefore, this method is widely used. RF cable, also known as coaxial cable, is composed of an inner conductor, an outer conductor, and a medium supporting the inner and outer conductors that are coaxial with each other. The figure shows a double-layer outer conductor RF cable, with one layer being aluminum foil shielding, and the other layer being braided shielding. A connector that supplies television signals to a television, also known as a user junction box. There are 2 types of user junction boxes: single-hole boxes and double-hole boxes. A single-hole box only outputs TV signals, while a dual-hole box can output both TV signals and FM radio signals, as shown in the following figure. Due to the nature of the project and the requirements of industry management, the installation and commissioning of building cable television systems, such as receiving antennas, front-end equipment, etc., are generally carried out by professional installation teams from the cable television department. Building installation units generally only lay indoor lines, install distributors, branching devices, and user terminal boxes. This is the entire content of this video. Please continue to follow the relevant videos of the Construction Equipment Installation Project course. Thank you.